There we go. All right. Okay. Plot one, number one. Turn it on, if it's not already on. Probably is on, I'm guessing. Press enter. Go down, select histogram, which is this little shebang over here. Make sure you press enter on that one as well. Now, chances are, because we did one of these last class, your X list says L1, and your frequency list says the number 1, I'm guessing. You want to make sure the X list is definitely L1, because that's where your data is. But what do you think that frequency list has to say? L2. Because that's where your frequencies are for the top finishers, yes? And your TI has to know that. Watch what happens if you don't. If you leave it at L1, 1 and you press zoom, that's not your data. Oh, just like, remember how you did it, Sarah, before when you did 1 bar stats, you press second 2? Exactly the same thing, my friend. You press second 2.
When does what frequency with the white list?
Oh, make sure you've changed the histogram, Richie. Make sure you're not on this guy. Yeah, hey, gotta press enter. Gotta press enter.
There it is.
I got a mouse for this. Click. Second 2. Yes, Rachel, thank you. Thank you. Second 2, get you L2. Fair enough? Once you're there, zoom 9. There's your data. Here's a question. Was Danielle correct in saying that most of the runners in the top were around 34 years of age? Parallel question, is the data roughly bell-shaped?
Yeah.
Hot damn, look at that. No, now some of you are going to say no. You're like, I don't think it's bell-shaped enough. I think it's bell-shaped enough. It's not perfect. It's a little bit skewed. It is a little bit skewed. I would agree. And some of you are going to ask, how skewed is too skewed? If you really want a number for that, in the homework for variation, I include a little section on something called Pearson's second skew coefficient, which I know turned all of you off right as soon as you heard that. It has an acronym, PSSC. And it gives you an idea of how skewed is too skewed. I look at that and I say, yeah, I see a tail on this side, a tail on that side, call it bell-shaped. It's a little bit heavy on the left side. It's a little heavy, but it's not crazy heavy. It's skewed a little.
Sorry, what did the graph in Jurassic Park look like there? What did it?
It's the graph in Jurassic Park.
Yeah, so like you said it.
Oh, my correlation with Jurassic Park, sorry, was, is it okay to use the average right now? I.e., is that data essentially bell-shaped? Yeah, so go ahead and use the average, because the average is not being skewed to one side. That was the point. The reason is, not so much that we're building dinosaurs, but should we build dinosaurs? So building dinosaurs is tantamount to using the X bar and the S. Since that's a bell, arguably a bell, go ahead and use it, because it's fine. It's fine. Please, Rachel.
And we determined obviously that the top, if you will, was the better average, so that's the average that we would then use.
Now the question is, how about the bottom? Can I come back to that question in a minute?
Yeah.
Let's look at the bottom as well and see if it's bell-shaped.
Okay.
Now, what I don't want you to do, and I'm going to show you what I don't want you to do right now. Of course, this is like riding a mountain bike and saying, don't hit that rock. But we don't want to turn a histogram on. I want you to turn a second plot on. But watch what happens if I turn a histogram on and look at L1 and L3. Watch. It's very confusing because it puts them on top of each other. So everybody do this. Don't you worry, do it right now.
No, I mean, I can't.
Second Y equals?
Yeah.
Okay.
Can I have all that?
Then you press zoom 9.
Boom. Zoom 9. Thank you, Daniel, again. Zoom 9 is the quick and easy graph shortcut to get you to this window. I'll keep reiterating that. Thank you for bringing that up again. I appreciate it. So now go back to second Y equals. Turn plot 2 on. But instead of using the histogram, which is that guy, use the one just left, which is called a line graph. You'll see why we're doing this momentarily. You'll see why we're doing this momentarily. I don't know what it's called. I think it's called a line graph on the 89 as well, and I'm not sure if it exists on the 86. But don't worry if it's not.
XY line.
I bet you that's it. XY line. Yep.
XY line.
It's XY line on you guys too. So Corbin and Jake and Valerie, XY line.
You're going to the barcode?
What next to this?
This is the histogram we just did, Rachel. I'm using this one now for the L1, L3.
Okay.
And then just make sure X and Y lists are L1 and L3.
Okay.
And as far as mark, you can leave it whatever it is. Go so far? After it's all set up, just press graph again. There's your bottom finishers. So if you can, And this is part of what this class is all about, is envisioning a smooth curve through the blocky curves. There's your curve for the top, or for the bottom finishers, excuse me. There's your curve for the top finishers, if you will. Say that again, Richie.
You get a little tail on
We
it.
do have a little tail. It's a little less bell-shaped than the top finishers. I still think it's arguably bell-shaped. And we're going to come back to a data set that it's clearly not, for sure. But do you see the larger standard deviation in the bottom finishers? Do you see the large? Let me make it a little bit easier. Do you see the fact that the blue curve is more disparate than the green curve? Yeah, if you fit a bell over both of them, the bell on the bottom finishers is squatter and wider. The bell on the top finishers is tighter and higher. And I love when this kind of crap just happens randomly in data. Because there it is. There's what we've been talking about in the Portland Marathon. Like, why would it be there? Because it's too hard for it not to be there. You'll see that over and over again in this class. Data just shows up on its own. You're like, oh, look at that, it happened in class. It's like when you sit in Math 111, you're like, here's a water rhythm that occurred in nature. No, unless you had an earthquake that just happened. But like all of a sudden, this data just shows up. Bell, there's a bell, isn't that wonderful? So you see, not only do you see the higher average, yeah, there's a difference of 10 right there, yes, there's the 34 versus 44, but you also see the greater spread around the average. Make sense? It's a way to analyze the data. Beautiful. Questions, concerns, technological hang-ups, anybody give any grief?
Yes.
Grief, Sarah, go!
Mine's not plotting.
Let's see. Did you press Zoom 9?
Yeah.
Well, let's see. Oh, I got something there.
That's beautiful.
Okay, you got plot one off. I'm gonna turn it on first. That's okay. Zoom 9.
There you go.
There's him. There they are.
Done.
Now, friends, this is all well and good, but why do we care that they're bell-shaped? Do you remember why we care when things are bell-shaped? We can use the average happily, but do you remember some percentages that we get when data is bell-shaped?